Okay, so just a quick review over relations and functions. You'll notice that this first example is an example that looks pretty similar to the one that we did in the notes. The only thing different is that I changed the relation, so I changed up the coordinates a little bit just to provide you with a different example. So we want to express this relation as a table, graph, and mapping. So the first, we have the table. And this is pretty easy. You just want to make sure that you write your coordinates right next to each other. The y, you want it to correspond with its x each time. So I have 3, 1, negative 2, 5, 1, 0, and 3, negative 2. And that's it for the table. Now when we go to the graph, we're going to plot these coordinates. Remember, the first number in your ordered pair is the x-coordinate. That represents the horizontal placement, so left and right movement. The second value is the y-coordinate. Represents the vertical placement, up and down movement. So I have 3, 1. So I'm going to go right 3, up 1. The next one is negative 2, 5. So that means I'm going to go left 2, up 5. 1, 2, 3, 4, 5. 1, 0. So 1 means I'm going to move right 1 unit, and then 0 means I'm not going to move up and down at all. I'm going to stay right at that axis. And then the last coordinate is 3, negative 2. So I'm going to move right 3, down 2. And there's your graph. And the last representation is mapping. Now, if you remember from in class, there's a special rule about mapping, and for these questions down below, if any x value or any y value repeats, you do not write it twice. Okay, that goes for x or y. So here's my x column, and here's my y. So in my x column, I have 3, negative 2, 1, and 3. So notice that I have 2 x's that are 3's here. I only want to write 1 3 though, because the 3 repeats. So I'm only going to write 3, negative 2, and 1. Again, don't repeat any values that are shown twice. In my y column, I have 1, 5, 0, and negative 2. 1, 5, 0, and negative 2. And now we draw arrows from the x to its corresponding y value. So I have 3, negative 1, so I'm going to draw an arrow from 3 to 1, negative 2, 5, 1 goes to 0, and 3 also goes to negative 2. And we have now represented our relation each of the 3 ways. The last thing we're going to do is state the domain and the range of the ordered pairs. So another way that this question might be asked is to describe the domain and the range, and that means the same thing. So remember, we use our set symbol to notate that we do in fact have a set here. So I'm going to say, all right, the domain equals, there's my set, my little bracket, remember S2. And just like the mapping, we do not repeat, we don't write any value that repeats, we only write it once. So I have 3, negative 2, 1. 3, negative 2, and 1. And now we close the bracket. 2s. And then the range. 1, 5, 0, negative 2. 1, 5, 0, negative 2. And we have stated the domain and the range of this relation. Okay, in problems in which you have to determine whether or not the relation is a function Really, there is just one simple, easy thing to look for. You cannot have any x's repeating in order for it to be a function. So, for example, in number 1, this is right from the notes. Notice how I have an x repeating itself. I have a 1 here and a 1 here. By definition, each member of the domain can only correspond to one member of the range. So to one y value, well, I have a member of the domain, which is 1, corresponding to both -2 and to 5. So my x's repeat, meaning that it is not a function. In number 2, we have a graph. This one's just a little bit different from the one in the notes, just to give you a different example. When we have a graph, what we can do is use what's called the vertical line test to determine whether or not we have a function. And all that entails is drawing vertical line. You can draw a couple if you want. And looking to see if that line that you have drawn crosses your graph in more than one spot. So in this case, I have the line intersecting the graph right here and right here. So when this happens, what this means is that this would not be a function because our x values would be the same. So if I were to try to estimate the coordinate of this point right here, let's say 2, 4, 5, 6, maybe 2, 6, and this one right here, 2, 1, 2, 3, 4, 5, 2, -5. Notice my x's are both 2, and in a function, x's cannot repeat. My 2 goes to 6 and to -5, meaning that this is, again, not a function.